So I need at least 10 minutes. Yeah. All right, so let's look at the question first. What we can do in application programs of databases. Yeah. So this part is, yeah, we already went through. Here I just summarize a little bit. Yeah. But after that, I want to talk about important question. Right. So in an application program accesses the database by sending queries to DBMS. Yeah. Because in our application programs, here we imagine we are in an environment. So we are writing programs in a typical web application. In this web application, we need to send many database queries to the database server. Yeah. All right, so what we can do, create a database. Because to create a database, we just send a SQL query statement. Create database name. That's simple. The command, SQL command. Create database, then you provide the database name. That's simple. Double quotes as a string. You send the string as a SQL query statement to the database server. So then the database server will create one for you. Assume you have the privilege to do that. Okay? Yeah. All right. Then create a table. Another SQL statement to create a table in a string. Okay? Yeah. So double quotes, a string, SQL statement. So you send it. Yeah. How to send? Yeah. How to send? Yeah. So after I finish these items, then I talk about that part, the program, the database connection part. Yeah. That part is important question I want to explain here in this slide. How to send? Yeah. All right. Create a stored procedure. We know to do that, just a sequence of SQL statements. No. So we can also do this. No. Call a stored procedure. Another statement, another command, SQL command. Then do other regular queries. So that's what we can do in the application program. But, so there is something related to the business decision. So I want to mention a little bit. Yeah. So here, in the programming side, you have the capability to do these things. Yeah. But for the top two item, although you have the capability to do that, but the top two items related to the database design. Yeah. Because when you do these things, top two items, so you modify the database design, right? Yeah. So think about that's a business decision. Yeah. Related to the business decision. Okay? So you need to, so it's another programming issue. So it's a business issue. Yeah. So you need to consider that. Yeah. All right. So then I want to talk about database connectivity issue. So this is a big, important question. So I want to explain. So here, I want to explain this, we call it database connectivity issue. Give you the description, how to connect, how to send SQL queries to remote database server. There are two ways. Typically, there are two ways. One way, the Java way, another PHP way. So these two programming languages, they do the database connectivity differently. Yeah. So they represent two different approaches. So I want to describe these two ways. Yeah. So one way, Java way. Another way, PHP way. Quite different. Yeah. First, let me explain the PHP way. Yeah. Because PHP way is straightforward, easy to understand. PHP way. Java way, a little harder to understand. Yeah. For PHP way, the question is, you need to work with different DBMS, right? PHP, when we use PHP to write our server-side programs, we may need to communicate with different DBMS, right? So here we use MySQL and Oracle, although there are many others. Yeah. But here, when I use examples, I just use these two, okay? Yeah. So when you need to communicate to different DBMS, how do you communicate? Okay. So here, the main idea is like this. Yeah. So for each DBMS, a set of special functions are created. A set of functions. Yeah. Are created. For the SQL queries. Yeah. So what's that? Yeah. For example, so here, for example, in order to send queries to MySQL DBMS, you need to use a set of functions. Start with MySQL, MySQL underscore, then some name. So what do you do? What do you want to do? Right? Yeah. Things like that. Okay, a set of, because you want to connect to database. You want to run the query, you want to execute, so then you want to do, several different things. Yeah. So you have a set of special functions with the DBMS name, MySQL here. Okay. Then, if you want to communicate with different DBMS, then you need to switch to a different set of functions. Okay, the Oracle set of functions, Microsoft SQL Server set of functions, and so on. Okay, if there is a new DBMS created, available on the market, then the PHP program creator, so they need to add a new set of functions to communicate with the new DBMS. So this is the PHP way, straightforward way. So we call this way straightforward way. Okay, yeah. So the typical property of this one is one-to-one correspondence of one. A set of functions correspond to a DBMS. That's the typical property. Yeah. Looks quite natural, right? Yeah. But the Java way is different. Java way is quite different. So here, let me explain the Java way. The Java way, the Java team, they want to do this whole database connectivity thing efficiently, in an efficient way, not this way. This way they do not feel efficient. So they want to make the whole thing work more efficiently. Yeah, so what's the Java way? Okay, yeah. Java here I talk about the technology called the JDBC. Refers to Java Database Connectivity Technology. All right. So for the Java way, two sets of interfaces created in order to make the database connectivity thing more efficient. Two set of interfaces created. So here, two interfaces. Let's say two interfaces. You know the interface concept in Java, right? Here I assume you know the interface concept in Java. Okay? Yeah. A list of methods. Okay? So the methods, how do you call input output? You know, list of methods, but without definition, just interface. Okay? So two interfaces, or more precisely, two sets of interfaces. Two sets of, because each set contains several interfaces. So two sets, specifically, two sets of interfaces, not just two interfaces. Okay. All right. The first set of interfaces that for DB database, DB vendors. DB vendors, okay? So the companies create the DBMS as their product. So the DB vendors. All right, so, oh, sorry. So I forgot to turn off. I always forgot to mute. Put in the airplane mode. Yeah. So the first set of interfaces provided to DB vendors. Yeah. The second set of interfaces for DB programmers, for us, the DB programmers. No, two set of interfaces, all right? Yeah. Yeah. So then, regarding the how to do the database connectivity, this whole thing, yeah. The DB vendors, what they use their interfaces, they need to develop the database driver. Okay? Yeah. So the here, DB vendor develop the DB drivers for their products, for their DBMS products. Okay? Yeah. So what's the driver? Here, let me explain the driver. So the driver, basically the Java library classes. It's a library, Java library. Okay? This library contains all the Java classes needed to communicate with the Java programmers. Do the communication between Java programs and DBMS. So the Java responsible for the communication. Okay? Yeah. The drivers for communication between Java programs do communication with their DBMS. Yeah, those DBMS. Yeah, because yeah. So all the classes doing the communication so in that Java library. Okay. All right. So then, we as Java programmers, we use the second set of interfaces to write programs, to write our query-related statements. So, programmers use second set of interfaces. In our program, in programs. Okay? Yeah. Like that. Yeah. So that's the typical Java. Okay? Two set of interfaces. Yeah. All right. So then, now, yeah. So we treat this as a setup. Okay? The setup. Then, when you work, when we work in our project, in our web application project, in order to apply JDBC technology in a project, in a Java web project, first we need to download the driver, Java library. No, only one file, okay? One .jar file. So the driver is something .jar. That's the Java file, okay? So provided in the website of the vendor. Okay? So MySQL in the MySQL website. So we'll provide a link for you to download Java driver. Okay? Oracle website. So provide a link to download Oracle driver .jar file, something .jar file. Okay? Yeah. All right. So after you download that driver file, you need to put the appropriate location in your project. Appropriate location. Yeah. So based on the Java EE. Java EE technology. Java EE technology. So there is a specification. In the specification, it tells you where to put the driver file. Okay? In appropriate location to put the driver file. Okay? So you put there. So after you put there, then you can write your code, Java programs, to use this DBMS and send queries, communication. All right. But when you write, you need to set up the database connection. We need to do that, set up the database connection. In order to set up a connection, DB connection, okay, in order to set up that, you need to provide URL of the database server. Where is the database server? You need to know that, okay? So you need to provide URL of DB server. Okay? Then username, password. Okay? Other than, yeah, because in order to connect the database, you need to have an account, right? You need to have an account in this DBMS. So when you have an account, you have username, password. Okay? So username, password. Okay? You need to provide username, password when you make connection. Okay? Yeah. Then, in your program, you need to load database driver. Load it. So that's just one Java class. You only need to load one Java class. After you load the database driver, then you can use the programmer's, the second set of interface, the programmer's interface, the second set. So use that. So you can, follow the standard procedure, step 1, step 2, step 3, how to do the query. Okay? So in the JDBC technology, so those 4 steps listed, you follow those 4 steps. So then you can send the queries to DBMS. So this is the Java way. The good thing about Java way is when you switch from one DBMS to another DBMS, so if you switch from MySQL to Oracle, you can keep a lot of things. So here, when you switch from MySQL to Oracle, first you need to change the driver first. Second, the URL of DB server should be changed. Username, password should be changed. Okay? Yeah. Then your query statements could be changed. Sometimes you need to change, sometimes you do not need to change the query statement. So that's the difference between MySQL and Oracle. You may need to change. Other than that, your Java code you do not need to change. Okay? So your Java code, because you apply the same set of interface. So Java code, Java classes and the Java method names, how you use Java classes, method names, you do not need to change. So that's the good thing about the Java way. Okay? But for PHP, you need to change the function name. So in Java, the method name, you use the same method name. Okay? Yeah. So that's the difference, main difference between these 2 different approaches for database connectivity. All right, so here I just give you the high-level description. For the details, to show you how to, the details, use examples to show you. I plan to use supplementary videos to show you. So if I see that part, I can record small videos to show you how to do it. Here, so that's the abstract way. So if you want to know the details, how to really make it work in a program, so I can make some simple examples to show you that in a few supplementary videos, so you can get a concrete impressions. All right, so that's this topic. So we finish part A. Data normalization issue. Data normalization. So in this part, let me explain this question in details. First thing, B.1, redundancy problem in a typical database. Redundant information. You store your business data in a redundant way. That's quite common in real-world applications. All right, so first let's look at the redundant problem. Storing the same data multiple times. Same piece of data, you may store in multiple places. That's the redundancy. Okay? So if you do that, so later we will discuss, why people store the same piece of data in multiple places. Later we'll talk about that. There are some reasons behind this problem. So if you in your database design, if you have this problem, redundancy problem, then the consequences. First, duplication of effort. Because when you need to update your data, so this particular piece of data, you need to perform single logical update multiple times. For one single data piece, because it is stored in several tables, and then you need to update all those tables. But those copies correspond to a single data piece. So duplication of effort, that problem. First, drawback. Second, wasting storage space. You need to use more storage space. Second, although in current IT industry, we know the storage cost relatively cheap. So if you do not use too much space, just a little more space, then people do not worry about that. Okay? A little more storage space, then nobody worries about it. Relatively cheap storage space, but it's a small issue. Same data is stored repeatedly, more space. But another problem, this problem is big, very, because inconsistent data. So it may cause potential inconsistent data. So when you store a single piece of data multiple places, and when you update that piece of data, then if you do not update everywhere, in all those related tables, you may make the data inconsistent. So files that represent the same data may become inconsistent. So what's the file here? Here, I need to explain this, the meaning of files. In our database concept, the meaning of this file quite different from our usual understanding of files. Here we are in a database context. A file means a table. A file means a table. So a file here means the tables that represent the same data may become inconsistent. So here, why in our database concept, one file corresponds to one table? The reason is simple. The reason, we need to go back to how people created DBMS. how people write programs, write all the programs for a DBMS. DBMS is a big software. So, the creator, the vendor, so they need to, do a lot of work to write large number of programs to implement all the features in that DBMS. How to store a table on the hard drive. Each table is stored as a file on the hard drive, okay? So the physical storage of a table is a file. One single file corresponds to one table. In the internal storage for a DBMS, so for that reason, so here, in our database context, when you see a file, it refers to a table most of the time. So you know this. Then you try to figure out if the file is really the meaning of table or our usual understanding of a file. So you need to try to identify what is the real meaning of the file. When you read articles, technical articles related to database technologies, so the files, yes, because each table is stored physically as a file on a hard disk. So we get this understanding, basic understanding of a typical table. Okay, all right, so this is the redundancy problem, all right, so the drawbacks. But we also need to discuss, there are some reasons to allow redundancy in database design. There are some reasons, important reasons. People need to use the redundancy. All right, so B.2, concept of data normalization. So let's look at this important concept in database design, normalization. All right. Ideal situation. So then, based on that redundancy problem we learned from B.1, so now, if, so first we just consider the ideal situation. The ideal situation means if we do not consider any potential problems, the best situation we want to have, that's the ideal situation. The best, we ignore all the potential problems. So then, what's the best situation we want to have? The ideal situation. It's like this. Store each logical data item in exactly one place in the database. That means no redundancy, right? Each logical data item. So that particular concept, that particular data piece, we don't want to store it multiple places. We want to store in only one place. Ideal situation. So here we ignore the potential problems, because if you really do in this way, there could be some potential problems. So here we ignore those problems. Later we need to go through those potential problems. All right. Logical data item. So what's the logical data item? So each data item has some business meaning, right? So because you use that data item to describe one specific, business aspect, to describe a business object, okay? aspect of a business object. Yeah. So here we use the abstract way to describe our data. A data item appears in multiple tables with different, so here, this sentence describes the typical situation people do in a database design. Yeah. So it's very common, one data item appears in multiple tables with different field names for convenience. Later we will see. Later in our database examples, we will see it's quite common. Okay? Two different tables, but one specific data item or appears in two different tables, and we intentionally use different names intentionally. Although you can use the same name if you like, but people like to use different names. The reason is simple. If you use the same name, you get confused. Okay? So which table I'm talking about, right? When you use this piece of data, which table you are talking about? You get confused. But if you use different names, then you don't have that confusion problem, right? Because their names are different. So later you will see this. So it's quite common. So one data item appears in multiple tables with different field names. All right. So that's the typical situation. For convenience. So here the reasons. Why you do that? You may ask, why you do that? For convenience. Because when we do that, then we can establish relationship among different tables in certain way. Relational database. Many tables are correlated. We need to establish some special relationships among different tables. So that's the most common reason people do in this way. Otherwise, how do you represent that two tables are correlated, right? How do you represent? Through some common field, okay? Two tables are correlated through some common field. So that's the idea, okay? All right, so here, let me give you the reason behind why people do this, okay? All right. How to make two tables correlated. Okay? Yeah. Through a common field. A common field, we know, usually people like to use different field names. In order to avoid confusion. Otherwise, you may get confused. Okay? All right. Benefits. So ideal case, the benefit from this ideal situation. Later we will know this ideal case is impossible to achieve. Impossible. Usually when people talk about ideal something, it's hard to achieve that. It can never happen. So that's why people say ideal. It can never happen. Okay? So the benefits of this ideal situation. First, save storage space. Now, you do not have any redundancy. Okay? So you do not waste any storage space. The first benefit. Second, easier updates. When you need to update one particular piece of data, you only need to modify it in one place. That's all you need to do. So the second benefit, okay? Yeah, one copy. And the third one, yeah, so this is a very important one, ensure data consistency. Because there is no co-relationship you need to consider, right? Yeah. You change this particular data in one place, it won't cause any problem in other places. So you have the data consistency. No, the benefits you have. All right. Then the question: should we always make our data normalized? Yeah. So the data normalization, the meaning is, so when we say data normalizations, we remove the redundancy in our database design. Okay? That means normalization. Okay? You eliminate all the possible redundancy in your database design, then your database is normalized. Okay? That's called a normalization. But the question is, should we do that? This question is important to answer in our database design. Yeah. So when you design your database, you need to know the answer of this question. Should we always make our data normalized? Yeah. So the answer is pretty complicated. Yeah. So the general answer is, most of the time, we may not want to make our database normalized. Most of the time. Sometimes, yeah, probably, sometimes in a very special situation, you can make your database normalized without causing any problem. Okay? Without causing any problem. Then you can do that, right? Yeah. But most of the time, because you have so many factors, yeah, other than things here, you have many other factors to consider. To answer this question, you need to consider, so here, need to consider many other factors. Okay. For example, the most important factor, actually the most important factor you need to consider is the performance issue. The performance issue, we know the query performance. How fast is your query? You want to make your database accesses very fast. That's the performance issue. So sometimes, in order to make your database queries very fast, you need to allow some redundancy in your data. You allow redundancy. Okay? If you eliminate all the redundancy, then you may need to do much more work in special, complicated situations in the real world applications. So I will show you some examples, because this question is very important. I need to just elaborate this question. Performance issue. That's the big consideration in our database design. So we always want to make our database queries as fast as possible. So it's a big consideration. All right, next topic, control the redundancy. So this terminology. We allow redundancy, but that redundancy must be under our control. So we use this concept, control the redundancy. So what's that, control redundancy? Why sometimes redundancy is not a bad thing? It's useful. Okay? Yeah. So we may need to use some special redundancy of our data to improve the overall performance of our database queries. All right, so let's so performance consideration on relatively complex queries. So let's look at this question. Performance improvement, this question. Okay, all right, yeah. Derived data comes from multiple tables. Here, let me explain this concept, derived data. Derived data, not original data, okay? Yeah. So our business, when we collect our business data initially, so we get original data. Yeah. So we store the original data in our databases. All right, but sometimes we need to generate some special set of data from the original data. That's the derived data. Okay? Yeah. So we have original data. Yeah. But for some reasons, we need to generate. So I will explain that in some reason. Generate derived data. For some good reason. There are some good reasons. Yeah. Typically, for the performance consideration. In order to make the performance faster, we may need to produce the derived data. Intermediate, you can call intermediate data, derived. Okay? Supporting data, supporting intermediate data, okay? Derived. Okay? So this concept is very useful in the real world applications. The queries to generate the data are relatively time consuming. So let me describe another situation that people want to use derived data. Related to the complex query, very time consuming. Yeah. Yeah. So in many business applications, sometimes your database queries could be very complicated. Okay? Yeah. So you need to write, so either some big complex query statement, or you need to write up, store the procedure to do some data processing. Okay? So the data processing work takes a lot of computation time. So here, so we understand. Yeah. Yeah. So two cases, so here. two cases. The first case, complex queries. Second case, use stored procedures. Stored procedures. But one thing common, time consuming. Okay? So when you run these complex queries or when you run the stored procedures, takes quite some time to produce the computation result. Okay? Think about that situation. Okay? It takes quite some time. Okay? Yeah. So you cannot get your query result immediately. Yeah. Because too much work. The DBMS needs to do a lot of work to generate, to produce the results. Time consuming. Yeah. Here, we do not say too long, so here, let's just say a few seconds. A few seconds. You may feel not quite long, right? A few seconds. Yeah. Even here, even I use simple example, let's say 5 seconds, okay? Yeah. So, that's just example. We know 5 seconds. If the computation time takes 5 seconds, although it's not too long, but quite significant, right? The 5 second response time, quite significant. But you can think about in the real world web applications, if your users need to wait 5 seconds for the response, then it's too long, right? Yeah. That experience, very bad. So your customers won't like that. Okay? You need to wait 5 seconds. Yeah. It's like a century. Okay? Although 5 seconds, but the impression. It looks like the program gets stuck by 5 seconds. Although you can tell, so you put some, progress bar. You put progress bar to let your customer aware, you need to wait 5 seconds, yeah, to make it a little better. Yeah, but still, you want to avoid that, right? You want to avoid that. Yeah. All right. So in that situation, so how do people solve that problem? Okay. Yeah. So the way to solve that problem using the redundant data. Data redundancy here is used to speed up the response time. Yeah. The solution is so simple. Okay. Yeah. So how do you? Yeah. How to solve this problem? Okay. Yeah. Faster access if we store. Yeah. So we store. Yeah. Because we run the complex queries or stored procedures to produce. After we produce the result, we store the result in other tables. We store it in new table. Okay, in new table. If you store a new table, definitely the data is redundant, right? Because it's not original data. It's derived data. It's not original data. We do not generate original data. We generate derived data. Okay? Yeah. It's derived data, not original, because if you throw away the data generated, you can produce the same data by running the same query or same stored procedure again, right? Yeah, just a matter of time, okay? Yeah. You spend more time to generate the same set of data, okay? Yeah, so it's not original data, the derived data. So here, you store the derived data in a new table, in a new table. All right, definitely it contains redundancy, all right? Yeah. But this redundancy is useful. You don't want to eliminate. So you create the redundancy. So you do not eliminate the redundancy. You add a redundancy in your database design. The benefit is obvious. Where your customers, the users of this web application, when they need to consume this part of the data, then you just retrieve from the table. You do not need to go through the long process, right? Time-consuming process to produce the data, because you already have the results stored. Okay, you just send the data from the table store. You already store it before the request from your customers. You send it back to your customers, and your customers receive the data immediately. So you reduce that 5-second waiting time, right? So this is the one typical way people use redundant data to make the performance faster. Think about it. Yeah. It's useful. Yeah. It's a good redundancy, right? Yeah. So we say this is a good redundancy. Yeah. But we must control the redundancy like this. Okay? So what do we mean control? Because if the data from the original tables modified, after some time, you need to modify a few pieces of data, but those pieces of data you use to produce the derived data, then you should update, right? Yeah. If you forgot to update, then you have the data consistency issue. If you forget update in the derived table, no, so the table store derived data, then you have the data inconsistency issue. Then it's disaster. So that may cause a big problem. Okay? Yeah. So for that reason, you should also update the derived data immediately. If you can do that without any problem, then we say you put that redundancy under control, under your control. Okay? So this concept we call it controlled redundancy. Yeah. So that concept, okay? Think about that. That's very useful concept. Yeah. All right, so here, yeah. So if we use a simple diagram, yeah. So we do this kind of replacement. The first block, a task we need to do in the first block, we need to do multiple table access with complex queries. Because some special data used in real-world applications, you need to access multiple tables, and after you retrieve the data from multiple tables, you still need to apply some special algorithms to do the data processing. Okay? Yeah. So that's a lot of work. That work may take a lot of time, significant amount of time. Okay? Yeah. Replace that block of that task block. We replace that block by another simplified block. So this block is single table access with simple query. Because this block, so we use derived data. We store derived data. Okay? Then we bypass the computation process. We just store the result. Okay? So retrieving direct result, that's very fast. Yeah. So this simple diagram tells you, why people allow. Yeah. And actually people intentionally, they solve the performance bottleneck problem using this way, using derived data way. Performance bottleneck. Right. All right, yeah, all right. Yeah. So this process people call it denormalization. Yeah. Just the opposite process of normalization. Okay. When you do normalization, you try your best to eliminate redundancy. But this opposite process, you go the opposite direction, you add redundancy. You add redundancy, but under your control. So you add a controlled redundancy to improve the performance. So this is called a data denormalization. Okay, yeah. And in your database design, so sometimes you need to do the data denormalization to make your database queries very fast. But you need to make sure the redundancy added, so you have to take care of the redundant data every time when you modify the original data. Okay? Yeah. Yeah. Keep track of all your derived data. Yeah. Otherwise, you get a data inconsistency problem. Okay? Yeah. All right. B.3, data denormalization. Yeah. So now I want to, let me just talk about, something general. So next time I will talk about important example. Yeah. Goal, simplify the computation. So if the computation is very complicated, we want to simplify it. To simplify it, we want to use derive the data to, reduce the computation time. Okay, yeah. So the view we take here, so it's a space performance trade-off. So you use more space to store your redundant data, right? More space, more storage space. But the benefit with more storage space, you can get a better performance. So it's a space performance trade-off issue. Yeah. And we know the space is relatively cheap, right? Yeah. So with the current, the cost of storage space, relatively cheap. But the performance improvement is significant. So most people, they're willing to use a little more space and with significant performance improvement. Yeah. All right. Right, you more space to exchange for better performance. Yeah. So that's a, good investment. Okay, pay a little more and get the benefit worth your investment. All right, so with more effort for data consistency, but you need to do more work in order to get better performance. Nothing is free, right? Yeah. So this benefit is not free. You need to pay more effort. So the effort you need to pay is when you need to modify the original data, certain tables in the original data, you need to take care of the data consistency issue. Do the updates everywhere. You need to maintain data consistency. So that's the extra work you need to do. Yeah. But that's important. Yeah. Worth the effort. So the effort you pay well worth it. Yeah. All right. A useful idea in application. Yeah. Before we finish, we just have a few minutes. So here, let me talk about this useful idea, and then I elaborate this important idea next time. Now, because it's a long story. It's a good story, long story. So I will elaborate next time. So a useful idea in application about what? About speeding up the performance. Okay, so we want to do that. Okay, yeah. Speed up the performance. Yeah. How to speed up? There is a special process we need to do. Pre-processing, data pre-processing approach. So we add a data pre-processing approach, pre-computation, pre-processing. That, from the name, you can guess the meaning. Before the user consumed the data, you did the data preparation before the user send the requests of the data. So that's called pre-processing. So this method has very big impact in business application. Huge impact. So why is that? Because the Google search engine uses this idea. Google search engine, okay? Google search engine. You know, Google search engine is a big, huge application, right? So many people rely on that, right? Google search engine. Yeah. But how to build a Google search engine? So what's the typical main idea behind Google search engine? This pre-processing approach. Okay. So the next time I will talk about the Google search engine main idea. So how to make it happen. Why, when a user sends a request, okay, the user can get immediate response. The performance is so fast. But the search result, large amount of search result returned. How does the search engine return large number of page information in such a short period of time? Okay? Yeah. Based on the pre-processing method. So next time I will describe that idea. Okay? Yeah. All right, so let's stop right here. Yeah. Oh. So this weekend I will post quiz number 2. Yeah. This weekend, yeah. Quiz number 2. Yeah. Covering module 1D. Yeah. So module 1 part D plus module 2 A and B. A and B, although we haven't finished just at this point, okay. B we have a few slides, but just at the current point, okay, at this point. So our second quiz. Yeah. Also, I will post project 1 description quickly, okay. Yeah. So I just modify my description slightly, then I will post in today or tomorrow. Today or tomorrow you will see it. Yeah. Project 1. Okay. All right, so that's it.